Okay. Lightning Talk session. I'm Pascal. I'm involved in the Dutch Ethereum community. And here's Frankie.
Why, hello. My name is Frankie. I work on MetaMask, and I'm going to give you guys the rules for the Lightning Talks. Or not?
Or not. So it's the one thing, this is the forward. So it's confusing.
Oh, gosh. Okay.
All of the speakers,
directions are irrelevant.
The clicker is confusing.
Okay, so we have 13 speakers and 109 slides. Each speaker is going to get a max of 5 minutes. If you could keep it shorter, that would be great. Audience, no questions. If you have questions, there's a Slack channel. I believe it's up there. If you think that the Lightning Talk Slack channel is a little too crowded for your questions, you can create your own channels, but use, or you can, they're already created.
Yeah, no, well, Lightning Talks channel is created. If you really want a room of your own, that's possible, then you use one of those hashtags. The hashtags will be displayed at the title slide as well.
There will be a countdown that will be displayed. I believe the countdown is being shown here. And when we go through the numbers, counting down from 5, we want audience participation.
Exactly. You will be policing, you will be the timekeeper. If the speaker is just in time, you have like 5, 4, 3, 2, 1. It's up to you to say 5, 4, 3, 2, 1. Applause.
You guys are on, the Ethereum Lightning Talk TV show. And then for speakers, once we get down to the applause section, that is a hard cut. I will take the microphone from you. I know I'm tiny, but I am also aggressive. And audience, please be generous with your applause. It's quite a thing to come up and talk in front of all of you.
Exactly, because we have some really accomplished speakers, but for some people it's the first time in front of an audience, so that's a good thing, and we encourage that.
Excellent.
So up first we have Frank Brinkkemper. Yes. Here you go.
Yes. Well, thank you. Thank you very much for the opportunity. My name is Frank Brinkkemper, and my talk will be about. It's fully on there. Nice. About secure enterprise use of a public blockchain for verifiable claims, and it's based on my thesis about an on-chain degree registry. Normally, I would go over all the terms you see and introduce all these terms individually, but I hope for this audience I can skip all that so I can directly go into the how and not talk about the why. So my name is Frank Brinkkemper. I studied business and IT at the University of Twente, and I performed my master's thesis at Topicus in the Netherlands. And well, let's just jump into it. I'm making use of ERC 780, and that's an ERC which is proposed by Uport, but I'm also using other ERCs like 725 and 735, and I see all those proposals work very nicely together. And those proposals are for the on-chain part, and for the standardization of verifiable claims, I use the block search standard. And so how would issuing a claim work? The flow is as follows. First, the issuer has a local claims issuance application, and they used that application to create claim certificates, so block search, and Merkle proofs, so they make a Merkle tree out of all the certificates, and they create that for the certificates they want to issue. Then they commit the claim to a local transaction database. It's a shadow database which is used for when the private key of the issuer is compromised, then transactions, an attacker can send a transaction with a claim to the claims registry, which is not in the internal shadow database, and then the issuer can immediately notice that with their local blockchain node, and then they can revoke the key who did that. And so it's safe to use this, in my opinion. So issuing consists of committing the claim or the claims that you want to your shadow database, then committing the claims to your local blockchain node, and you do that with an, other way around, with an action key. And the action key is the ERC 725 contract, so that's a identity smart contract. And the action key commits to your personal claims holder contract, that's ERC 735. And then if and only if the claim has been for 1 week in ERC 735, it can move to the public claims registry contract, which is ERC 780. And while it's issued, the claims are off-chain, sent to the receiver, and with all the proofs, all the Merkle proofs. So only the Merkle root is stored inside the public claims registry and nothing else. Then, of course, verification is also interesting. The other way, yes. So verification flow works as follows. You say to, for example, my company Topicus, they have a website to verify it. You say, I am Frank Brinkemper, find my claim at the contract location of issuer this, and key location this. If you want to know more about this, I don't have time, so you ask on Slack. You set the certificates, you sign it, and then they can use the information to get it out of the contract, and the resulting hash, you can make sure that, for example, the claim of FCC that I presented here, they can use, they can claim it in this registry, and I can use it here. Thank you very much for your presentation. If you want to know more.
Great job.
You have the clicker.
I do have the clicker. Oh. Did I accidentally click?
No?
No. Oh, I have
Up
to.
next.
Oh, next. Okay. Oh, I see. I go the other direction now.
So up next we have Lucas Gabriel Vera.
So you click down to go to the next slide, and you have to you hold it. Sorry, you click down.
Next and previous.
Next or previous,
Okay, so next.
and you hold it this way.
No. Okay, that's previous. Okay. Hello, everybody. I'm Lucas Vera. I'm from Argentina, and I came to present you Crypto Cup, the first World Cup prediction game based on a ERC 721 token. So just to give a little bit of context, we are 100 days away from FIFA World Cup 2018 in Russia. So what we are trying to present here is a project where you will be able to predict the 74 matches of the World Cup, that is the 48 matches of the group stage and the 16 group of the knockout stage, and you will be able to say on the group phase actual results, predict as a result, like 2-1 for Argentina, or in the knockout phase, the result of a winner-loser game, like Argentina will win 2-1 over England. So what we are trying to propose here is to make your prediction on this token, and based on your prediction, you will score points, and if you are on the 10% top point position, you will have a prize. Price depends, of course, on the number of players of this game and on your position, of course. So, how does it work? It's typical FIFA World Cup situation. You've got groups, you've got knockout phase. You just say, in this case, Russia will win 2-1 over Egypt, and you do the same for the 48 games. Then, based on your predictions, you will have the knockout stage, and you will say, I don't know, Russia will win to someone. And for all 64 games until the final match. Some extra info, there will be an early bird moment where your ticket, entry ticket, will cost approximately $30. It's valued in dollars, but all transaction will be on Ethereum, on Ether, and payouts, as I said, will be next week after the World Cup ends, and it depends on your position. Here, as an example, we're saying that if 10,000 players get on the game, first position will get $35,000, and which is funny, the last one, the one that got the least good prediction, will also win something. So that's the idea, everyone can participate. So what's so special about our game? It's token, the ERC 721, for the one that do not know, it's CryptoKitty. It's based on this token, which is interesting because its price will be valued by actual price spot, all of the players, not like CryptoKitties. But also what is interesting is this 100% custom made by you, no random. You choose all the prediction and you create this token at the moment of transfer. It's all about you and your prediction. What is also interesting is that your prediction get tokenized, and then after the first match of Russia 2018, there will be a second market where your prediction will get more and more valued, or less and less valued, based on real information of the real World Cup. So that in that exchange, you will get to exchange your prediction for Ether. So what's the roadmap? What you should know is that basically on 8 weeks from now, on May, we'll start a token generation, and you will be able to make your predictions, and that will last 4 weeks until the first day of the World Cup, and then that first day, no more prediction, only exchange. And 1 week after the final of the World Cup, you will get your prize, whatever that is. So you can contact us, support us, give us your feedback, and we are starting a proof of support campaign where you can help us to promote this game, and there will be drawn every week since the token generation event, where you will be able to win jerseys like this one I'm having right now, and I hope you can participate on this game. Thank you very much. Have a great World Cup with Crypto Cup.
So up next we have Alexander Krupjenkin. So maybe a little note for the speaker. You can also see the timer here. That's good that you have a look at sometimes. And the projection, it's a bit smaller there, but the full slides are up there. So no worries about that. You can just concentrate on the screen over there. Okay. Go ahead, Alexander.
Hello, everyone. My name is Alexander Krupjenkin. I am Aerolab software developer. In my presentation, do brief overview how we can use Ethereum infrastructure for smart factories and smart cities. Some words about me. I got master's degree of mechatronics and robotics, 6 years works with robots, and the last 3 years I developed Ethereum platform application. For my work at Aerolab, I develop software architecture and choose Aera project technology stack. What's about team? We love Ethereum. We support Ethereum before mainnet launch, and in 2015 we show first world drone driving via smart contract. And this time we start to make research and experiments around human-to-machine and machine-to-machine communication. And now we have an open source platform for integration of smart factories and smart cities. Just imagine brave new world where all of things connected to the internet and all manufacture is lights out and without the humans. How customers interact with smart factories. Half a year ago, I was in Internet of Things World Congress in Barcelona, where IT companies like Google or Microsoft showed his vision about this. As you can see, this scheme is broken because money and technical data are separated. And customer cannot trust in this data because IT company can change data in any time. And I have a question. Maybe we already have a solution for customers that can pack the technical data and economical data in one transaction. Yes, Ethereum is a peering network for communication between customers and smart factory. And smart contracts helps us to pack economical part and technical part in one transaction. But Ethereum is not enough. For example, we need a market to help customers find the smart factories. We need a third party who validate smart factory production. And we need a software distribution to integrate smart factory with economy. For this reason, we develop open smart platform for smart factories and smart cities. And I believe that only talented developers can implement new open industrial world. For this purpose, we start developing bounty program. And if you are interested in this project, you can email me and say, Alexander, what's about bounty program? Thank you for your attention.
So it's always good when people finish early, because as you notice, we have 13 speakers, and that doesn't really fit in 1 hour, but it's thanks to Alexander that we'll be able to do that. Up next, Kai.
Hi everyone. I'm Kai Bakker. I'm a software engineer from the Netherlands, and I started a small project a few weeks ago. It's called Get Solidity, and the idea is to document every single contract on the Ethereum blockchain. There are a lot of there are a lot of different contracts out there, and we see that the last year actually, a lot of contracts got deployed, and there is always code that implements this certain contract. But a pattern that I've often noticed is that the contract that is, the company that made the contract also is the builder of the software. Think, for example, of CryptoKitties. It's the same entity that builds the contract and builds the clients. And I think that's not really what we want for a decentralized system. We want a place where one contract is used by a dozen different clients and different pieces of software. So there are a few different stats that I want to call out. Currently there are over 2 million contracts deployed. According to Etherscan, around 17,000 have verified contracts, but maybe only 100 of them are documented. So they have documentation code for programmers to implement these contracts. I created a website, getsolidity.com, where you can find contract data from currently 20,000 different contracts on the Ethereum blockchain. I gathered a lot of API data and to match it all together and put it in nice documentation pages that every developer is used to read. There are two parts actually of this project. One part is the and I want to create an API where you can easily grab contract data, and that is structured according Truffle's contract schema, if anyone is familiar with that. And possibly in the future we could also add Solidity code or Viper code, maybe bytecode instructions, depending on what's valuable for the community. The second part is, so the first part was the API. The second part is a nice documentation page for every single contract out there. Currently, these documentation pages are built up from the data that I could collect. So they're missing the description data, and a nice description would be good for every function, but it's currently not described everywhere. So I need a community of people who want to describe all these functionalities of the contracts out there. That's why we come to this slide, the contribute slide. I would like input from the community. What would be valuable? What are you missing in this area? Are there certain parts of, are there certain problems for developers that are currently out there? Input would be nice. If you want to add descriptions, contact me, and we can find ways. If you have a contract that you want to be written out, added, ask me. And if you want to help with development, also contact me afterwards. Here are a few links. Currently you can find the site at test.getsolidity.com. You can reach me on Twitter. You can find the handlers downstairs. That was it. Thank you.
So I know the slider is confusing, so if you hold it like this, which is the natural position, remember to slide, next slide to slide down is the bottom button. Up next, Vincent Le Gallic.
So this is the one that goes for the next.
Hello, my name is Vincent, and 1 year ago I decided to create my first dApp on Ethereum. Oops. Fail. Maybe with a... Okay. And this is the title of my presentation. And at the beginning of this new challenge, this is me and my skills, iOS, PHP, and drawing. And do I have enough knowledge to make this application? The answer was clear, no. But I made my first website before understanding TCP IP, and it worked. So, I learned a lot during this creation. And the other main reason that we always have the choice between discovery and ignorance. Lack of knowledge results in a lack of humility. And when you are here, your perception of your size of ignorance is wrong. So I finally choose the discovery option. And there is my plan and some tips. First tips, do it without understanding everything. For example, in this article, your first dApp Studio, you have a lot of information about test RPC, Rep3, or Truffle, Solidity, and getting started is the hardest step, and if you don't understand everything, it doesn't matter. Tip 2, do not be afraid to look silly. There is a real question, and it's my answer. It is my question and my answer, and I'm ashamed, but finally beginners upvote this answer, and today I have a good reputation on Stack Overflow. So there is always something positive. Tip 3, talk with others, and they are here for that. And I personally meet people from a famous company, from iExec, MetaMask, or Kleros, and thanks to Assets Meetup, so it is a real opportunity. I'm going to talk Charity Chain, my project. It is a non-profit and open source project, and Charity Chain is the first crowdfunding platform on which fundraiser must give first. It is a very simple project. The author creates the campaign. To create the campaign, he must drop 50% of the goal of the campaign of the smart contract. He defines the beneficiary of the campaign with the wallet address of the NGO, and he defines the end date of the campaign with the date. After, the author can share to his network, okay, I deposit 10 Ether, for example, in this safe, and I challenge you to unlock them for this NGO. If the crowdfunding campaign is successful, 100% of the money goes to the NGO, else if everybody is refunded. It's a very, very simple project, and you are welcome on GitHub to contribute and make a code review. You are welcome. So about the title of my talk, Learning Ethereum Alone. On the Ethereum community, you are never alone. All these people encourage me to continue my project, and they give visibility, and it is very cool, and it is very encouraging. So it is an occasion to say thank you. And I have a big announcement. I have a partnership with a big NGO, and this project will serve a great cause, and it's really cool, and it's crazy because this NGO awarded the Nobel Peace Prize. And about the question, it's complicated. Yes, it's complicated, but nobody says it's easy to change the world. Thank you.
I wanted to give you 10 more seconds because of the clicker issues. That was my fault, but the audience was sorry. Up next, Gustavo Guimarães.
Oh, hello.
How do you change this?
Oh, yeah, here. Sorry about that.
Hi, hello everyone. I'm here to talk about an interesting project that I was given to. I have a friend in Thailand who's building like villas. Like he has 5 villas that he's gonna build, and he wants to. And he said, Gustavo, these villas are 1.1, around 1.1, 1.5 million each, and I want to do something unique with one of them. I want to raffle one of them. For those who don't know what a raffle is, like you create like a lotto, and then you buy tickets, and then whoever is the winner, you get the prize. So. And in this case, the price is a villa, right? It's a big house. So the road to raffle real estate on the blockchain. So I was like, oh, this is a very, very cool project. I wanna do it. This is something completely different from ICOs and tokens that's given to me. So I say, okay, cool, I'm gonna do this. So I was thinking about, okay, how can I do this? I can like have like a fixed price for each ticket, but then what if the volatility changes like every day? So it's like very interesting problem to solve. So basically the idea was like, okay, I need to create this like as a decentralized like smart contract, and the raffle has to be like some sort of like automatic system, like people buy into it, and then at the end, at some point, there's like a random number generation event, and then there's a winner, and then like the transfer of the villa to the winner needs to happen in a sort of like a fair, decentralized manner. So it's a really interesting problem to solve. And actually, this is the picture of the house. It was in Forbes like, a few months ago. And actually, I created a prototype over last weekend with at a hackathon in Berlin, and it was pretty awesome. So basically, the architecture that we created was like there's a web app and a blockchain and 3 smart contracts like raffle, and then all the funds like goes to an escrow smart contract. And then at the end of the raffle, there's an event that happened. There's another call to the raffle smart contract that generates a random number via Oracleize. Oracleize has an amazing API for that. So yeah, so this is like a picture of the app. The app is online. If you want to know about it, I can send you the link. I just didn't have the time to put the link here. So yeah, this is like something that I played with. And you can buy tickets, and then use MetaMask, awesome tool that you guys are creating. So yeah, and then towards the end, there's like a random generated event, and then you get the villa. So I have still 2 minutes. So I actually want to talk about like 2 things that I'm thinking about, like how this can be improved. So this first prototype I created with like fixed price per ticket, right? A person can buy as many tickets, but then it's like fixed price. And then I was thinking, okay, how can I like do away, if the villa is gonna be $1.1 million, how can I, put this into account, right? So I thought, okay, maybe I can create a raffle and people can buy like shares of the raffle. And then at the end, right, maybe the owner, right, the raffle owner can check, okay, is this like 1.1 million already? If it is, so then the collected ether, we calculate the collected ether and then calculate the proportion, how much ether you sent, and then from that proportion you get like you weighted, right? Your whatever you put in, then you have a weight towards the raffle, and then your chances of winning it is higher. So anyways, it's something that it's gonna happen. I'm gonna raffle this villa. And yeah, so if you guys want to keep posted on that, let me know. This is my Twitter handle. Yep, this is it.
Up next, Eugene Aseyev. So when Gustavo looked at Frankie when he mentioned MetaMask, that's not a coincidence. Frankie was too modest to introduce herself, but Frankie is one of the original 4 developers of MetaMask. So all of you using MetaMask, that's thanks to Frankie.
Hi guys. I will not cheat. Cool. My name is Eugene. I came from Singapore, and I would like to talk about Chainstack. So what is Chainstack? Chainstack is an idea of a platform that will ease and simplify connection of businesses with blockchain. So to give a short background, we are a team of seasoned entrepreneurs and leaders in both R&D and business space. So we have a team of people who have built companies, successfully deployed and ran multiple platforms in production. So we have some experience in that. We also played with the blockchain for last couple of years. We released a product called Acronis Notary, which is basically a trusted timestamping platform based on Ethereum blockchain. And then we thought about, okay, currently it's very difficult to work with blockchain, regardless what blockchain we are talking about. For Ethereum, the ecosystem is very powerful. There are a lot of tools and frameworks that can help you to develop smart contracts and deploy them, and so on and so forth. For other blockchain platforms, it's not as easy, and especially if you're a business person, you are very afraid of working with blockchain because currently blockchain is being built by a lot of, let's say, crazy people and a lot of nerds. So if you're a typical business person, you most likely will not approach these guys directly in order to have some blockchain running in production. So we thought about why not we take these 2 groups of people, business guys and blockchain developers, and combine them together and make some convenient platform for businesses to use and to build their private blockchain solutions. So the idea of the platform basically is to have several critical components like management or orchestration, and at this point we think that we'll be cloud agnostic and blockchain agnostic, so we'll be running in all public clouds, And we currently think that there will be no such a thing as on-premise. So even if you're running some sensitive operations, you most likely will be running those on some private cloud. So we think that everything will be running in the cloud mostly. So we want to run our nodes and networks in the cloud. As for blockchain networks, we plan to support a number of those, including Ethereum, of course, but not limited to. Inside this management component, we plan to have universal API, message bus to integrate with existing business applications so that it will be convenient for business developers. Also, we plan to have a services hub, which will include a number of useful decentralized services for businesses to use and to leverage, and to have universal APIs for these services as well, so that if you're a developer in enterprise, you don't need to figure out, okay, how this service works, how this service works. There will be a unified platform for that. Another important component is marketplace, and marketplace is a compound of two things. One is smart contract marketplace, because if you think about business use cases of blockchain, in some cases they're very, very similar. For instance, if you take land registry, you have huge number of countries, and land registry seems to be very similar from country to country. Of course, you have different integrations with the legacy applications, but in general, land registry is quite simple. So if you want to implement land registry in your country, instead of just going and Googling for some smart contract and then hiring a team and so on and so forth, you can just go inside the platform, buy a template of land registry and deploy it on our own infrastructure, which is running in public clouds. So that's the idea. Another idea of the marketplace is to provide developers, blockchain developers, opportunity to develop components of the system, which will be later open sourced, and get some rewards for this in form of tokens. And I will discuss a bit on this later. And there will be a number of other services like security, verification of your contracts, and of course technical support. Integration with billing and payment systems, so that you will not have to create wallets for each blockchain that you want. It will be all managed. So the most interesting thing is ecosystem, and we are currently thinking about this, how to connect these two groups of people, business developers and blockchain developers. And we think about this incentivization scheme when developers that can do development on blockchain can participate in the platform and get rewarded via tokens. And using these tokens, you can actually pay for the services on the platform. If you're interested, give me a note. If you want to participate, send me an email in the email. Thank you very much.
Up next, Pierre-Éloin Rétoré. Pierre-Éloin. Oh.
Hi, everybody. I'm Pierre. I'm French, and I live in Denmark. I'm part of an organization called WeOU with Imad that is going to talk afterwards. And today we're going to talk about the Energy Collective. So WeOU is a social launchpad. So we launch social experiments around emerging technologies, and our purpose is trying to figure out how we can change society so that it's more sustainable. So we have a few projects running, and some of them are really at this inception. So the Energy Collective I'm going to talk about, we want to work with local currency, community crowdfunding, we work with urban farming, and then fractal flows is going to be the next talk. So Energy Collective. So I live in Denmark in a hipster community. It's a Danish community. We own our own house. You can see where I live. But we also have like a common house where we eat together 3 times a week with my neighbors. We share our kids, they come and play, we share our food, we eat together, we share our car sometimes, and say, hey, we could also share energy, right? That would be cool. So we have like solar PVs on each houses, but we quickly figure out that like in many other countries, there's like tons of regulations about electricity. So we can actually share hot water between us. We have like a collective heat pump, but when we want to send electricity from let's say my house to my neighbor's house, then there's like my electricity company, there's a local distribution company, global distribution company, there's a government that wants a tax, and then there's even more taxes on top of it. So at the end, it's like there's so many things in between us that we can't really do anything. But now we have blockchain technology, we can decide, we can create a social agreement where the electrons are going. We can't really decide where they're going, but we can make an agreement where they're going. And then we figure out that there is part of these taxes we're paying each time we send electricity to our neighbors. There is like a research fund. So we say, hey, why not applying for a research fund to do this? And then we contacted all the companies that are in between us, in between my neighbors, and they're all part of this project. It's kind of cool. So the project is about looking at new social construct you can create with this type of setup. So our setup is quite unique. We all have solar PVs. We have like 3 networks of energy, 1 electrical network, and then 2 hot water network that is connected to the common house where there is a heat pump. And we have started to experiment with blockchain technology. So in December, we did our first peer-to-peer energy transaction between my house and the common house using Radon. So we are like sending energy back and forth. In June, we plan to do another proof of concept where we will charge an electrical car using several houses. And then we have other ideas a bit more crazy, like we want to create a kilowatt-hour token that we can exchange between neighbors so that when I have too much energy and my neighbors need it, then we can just swap this energy debt around without associating money to it. And you know, there's all kind of application we could look at, like battery charging, local energy markets, CO2 footprint calculator, these kind of things. So we're going to look at different types of technologies, and so far we looked at Radon, but we want to look at the Proof Authority, Energy Web Foundation, Plasma, Swarm, IPFS, you name it. And we are an open organization, and we really want to, you know, include as many people as possible into our new social construction. So one way we want to do that is by inviting you guys to come and play with us into a hackathon. So we're going to do it in Denmark, in Copenhagen area in April, and you're all welcome to come and play with us. It's going to be awesome. And then, yeah, if you have some crazy ideas about new social construction we could create with blockchain or something else, you know, just come talk to us, and maybe we can figure something out. Yeah, thanks.
Again, as a reminder for speakers, we need to mirror those displays, and the resolution is different. So it looks a bit shrunk there, but your slides are totally okay online. But you can concentrate on this screen. Up next,
hello,
Imad Abdallah.
All right, my name is Imad, and I'm here to present Fractal Flows. Fractal Flows is a collaborative system to emerge consensus from scientific claims on the social media. So to start with, I will give you some real-world claims that you can find on the internet today. And one of them is by a startup that claims that their apparatus or their machine that they created can substitute or has the environmental benefit of up to 275 normal urban trees. So if I'm an investor and I see something, a claim like this by a startup, I would be very excited. I want to invest until I start seeing the actual science behind this claim. The second real-world claim, which was made by a guy on Reddit or somewhere, where he says, well, proof of work is the only Byzantine fault-tolerant consensus algorithm that works so far. It's a mouthful. I don't know if it's true or not. And so is it true? Is it not? I don't know. The last one has real-life consequences. And when people make such a claim, it can have an impact. And it says the lives of tens of thousands of premature babies could be saved by simply delaying clamping the umbilical cord by 1 minute. If I were a doctor where this is actually a problem, I would like to know how the doctor actually performed first of all, is it true? Is it not? What kind of statistics was made? If I were a doctor, I want to know what were the medical conditions behind this. So the bottom line, I would like to decipher true claims, false claims, and emerge a consensus about scientific, specifically, claims. And for that, we created a tool. It's a very simple tool. It's called Fractal Flows. So fractalflows.com. You can go and look at it right now. It's up and running. You can host claims on Fractal Flows in 2 ways. Either manually, the good old copy-paste and fill a form. Otherwise, we have an integration with Twitter. So if you see a claim that says global warming is a hoax, then you can do a hashtag #FFClaimIt, and it will port the claim, host it on Fractal Flows automatically. And you let the game begin. So the first step in this whole process is to collect real hardcore evidence, quantifiable stuff, And we call them knowledge bits. So that's experimental data. These are simulations. These are mathematical proof that can either refute or support the claim. So it's either or. It's not one way. The next step in juxtaposition to hardcore evidence, they are opinions. We all have opinions about stuff, about claims. So in this case, instead of saying thumbs up, thumbs down, instead of saying I agree or I disagree with a claim, we worked with some friends from Considerate. We integrated their tool into Fractal Flows. And in Considerate, you can have a range of voting. So you have range vote. So you have a range from I completely, absolutely disagree, I'm indifferent, I agree, I disagree, I absolutely agree. And when hundreds of people actually participate in such a vote, you create a social histogram of opinions. Meaning you can see where the highest density of opinions regarding a claim lies. But more interestingly, actually, you can look at outliers. And outliers who are associated with arguments. So basically each argument, when you vote, you have to give your argument as why you voted the way you voted. And when there are outliers and you figure out actually these are really interesting outliers, so they may be actually correct compared to the rest of the society who voted on this claim. So at the bottom line, we would like to be able to differentiate between true claim, false claim, or claims in between, and emerge some kind of a consensus in between the evidence which was presented. So we have a map, hard evidence. We have a map of social histogram and opinions. How do you merge both maps to create some kind of a truth on a given claim? So if you have genius ideas and you think this is something interesting for you, please join our project, and we're happy to have you. Thank you.
What we didn't mention, this is like any talk, of course, being live streamed. So hey, people from live stream. So people in the live stream can actually use those same hashtags like LO1, LO9, L10, etc. And if you're a speaker, just go browse through the comments afterwards, and you can, you can reply to those comments. Don't make it a cesspool, people. Up next, Peter Murray.
Hi, that's me. Hey guys. So my name is Peter Murray. I'm with a project called Optionality.io, and we're working on decentralized on-chain options and futures exchange that we're just getting started on. And I want to tell you about a little story about some technological problems we had and how we solved them, and how we're sharing them, and hope that this could be useful for folks. So I'll give a quick background, and then I'll show some code. So our system, as it's architected, requires that we deploy lots of contracts. So we deploy a contract for every option that is written on our system. And the contract complexity is not insignificant. So these are large contracts, and they're quite costly to deploy. However, they're identical. These are identical contracts with the exception of the initialization parameters. So we really wanted to be able to take advantage of some of the library and the delegate call functionality available in the EVM. So you would think initially libraries might be the solution. Deploy once the library and share it across all of your instances. And this worked okay and saved us some gas, but it still seemed too high per deployment. So our contracts have many entry points, so we had to copy that code down to the contracts to then delegate to the library. So what we wanted to do was come up with a lightweight mechanism to duplicate the contract behavior 100% with an entirely separate address and an entirely separate memory storage space for the clone contract, if you would. So we would deploy one template contract and then make multiple clones. That was the goal of what we set out to do. So delegate call is a huge win for us. It does exactly what we want. It delegates the call to some other code at another address, but uses the memory space and the calling context from the initial call. And then in Metropolis Fork, we got the opcodes for return size and return data copy that allows us to dynamically return whatever was returned from the call that we made in our delegate call. So we decided to try to set out to make as minimal a contract as we could to implement a 100% delegation of all function calls to our master copy, and then have a little lightweight clone that we could deploy, little shim contract that we could deploy for each of our new options. So here's our solution. This is the bytecode that you need to deploy to create a clone contract. It's our minimal solution. that we found. And actually, there's one little hack that can get you a few more bytes off of this. You can see in the middle of this, this bytecode the BBBBB pattern. That's where we actually overwrite with the address of the destination contract that you want to delegate to. And the rest is the bytecode that deploys the contract and then sets up the automatic delegation and returns the dynamic values. So 62 bytes, and it costs 67K gas. So I don't know if you saw on the first slide, but our initial gas cost to deploy per contract was $2.5 million. So we went down to 64K plus some initialization costs that gets us up to about 150,000 gas. So big win for us and hopefully for others. We've bundled this into an open source package that looks like this. This is the clone factory contract that you can take off of GitHub and then inherit from it and basically call this function with the address of your target contract that's deployed once, and it will stitch in the master contract address and then deploy a clone and return you the address of the clone that you can then use going forward. So this is again available from open source. The little additional hack, which I think I have time to describe, is that you can use the vanity address generator for contracts to actually take off some additional bytes if you generate a vanity address with leading zeros on the vanity address. And we have contracts that will support that in the open source project on GitHub. Here is the project. You can npm install it directly, or you can go take a look at the code right on GitHub. I will put the warning up here. This is the same technique that the parity wallet used, and you have to be careful to make sure that your master contract is fully locked down and doesn't inadvertently destroy itself or do any other things that might have magnified impact, because it's the same code across all of your instances. That's all I had, and thank you very much.
Up next, David Lopp. Shouldn't be sleeping.
Hello, I am a researcher assistant at the Complutense University of Madrid, and I'm working on blockchain and distributed web applications. We have a side project, me and my group, that we are trying to disintermediate the science publication and dissemination and also peer reviewing. As you may know, open access movement is something that in the late years has raised a lot because of the systems that have been the publishers of the sorry. In the science, there are the publishers, the journals, the authors, and the reviewers, and the publishers are getting all their profit because they put that paywalls, and we think that we can just erase them from the ecosystem and keep with the journals and the scientists. So, we can do it with decentralized technologies. One of the first things that we need is a decentralized file system to publish the papers. So the authors can just share the papers without having centralized organizations that provide those papers on the webpage. But we also need a system to peer review those papers. So we need some smart contracts so that we can know if a paper has been rejected or has been accepted. On top of that, we can build also a reputation system in which we can review the reviewers. So in that way, we can make the process more transparent, and it can also improve the time publication, the time of publication of new papers. And of course, this system can also introduce new problems because of the decentralization and transparency can also, well, we need some privacy. For example, for the blind review, we need something to protect the privacy of the reviewers in some cases or at some point in time. So we have also to see on the net or privacy coins to see how to accomplish that. And also we can think on how could we understand the science without those third parties that are also, well, the journals. How could we make those journals completely automatic? And that's all. We have the web page, and if you want to join and share or just get informed about, we have a newsletter. And thank you.
So as you know, you can actually only fit like 11 time slots, 5 minutes an hour. But because Guoyang and Scott are so generous, they're the bosses of this room, we can have 2 more talks. So up next is Nadim Kobesi.
Thanks. Cool, thanks. Hi, my name is Nadim. I'm using this very extremely hard to read thing because I unfortunately did not have time to send better slides. I'll make this quick. So public ledgers, there's a lot of public ledger designs out there. It would be nice if we could quickly be able to separate the good public ledger designs, and especially the coherent ones that actually satisfy the goals that they set out to satisfy, from the public ledger designs that simply do not do this. And I'm talking about public ledgers in terms of data structures that sort of like have to guarantee integrity in particular ways, depending on whether it's a public ledger, for example, to follow through a voting system, one to follow through the, for example, a public ledger recording the bank transactions, which are different types of structures of public ledgers, but essentially both of them want to verify confidentiality, authenticity, integrity, depending on the use case. And so that's why I'm working on something called Ledger Design Language. It's a domain-specific language for sort of describing what a public ledger is. And so that's the input of the language. And then Ledger Design Language, LDL, there's an LDL compiler that produces 2 outputs. The first output is a representation of the public ledger as a protocol in the symbolic model in the applied pi calculus. And from there, we can verify it as a protocol using the ProVerif automated verification tool. And we can obtain results on it as a protocol running in the real world. Does it actually satisfy consistency according to the use case, integrity, and so on? And another thing, so the second output of the LDL compiler is an actual API implementation of the ledger as a client and as a server. And the actual API implementation, which you can then use in production, is written in a new programming language called F-star, which is an ML-like programming language that is sort of geared towards formal verification. So in F-star, it looks a lot like OCaml, but at the same time, it allows you to represent types as proofs. So for example, and this is an unrelated example, but like algebraically, say for example, you want to implement an elliptic curve thing in F-star, you could type a certain variable as a point on the curve, and then F-star would use that3 to verify that this is true. But also, this is the same, for example, in the context of public ledgers. This would be the same because then, in this way, you could type, for example, valid blocks, you could type a valid signature, you can type a valid public key, and in this way, F-star is actually a whole like holistic sort of programming language for producing formally verified programs. And then in this way, when you create a public ledger implementation in F-star, you immediately obtain guarantees on sort of formal correctness and actual functional correctness of execution of the program. And so ledger design language is going to be presented in a longer paper at IEEE Euro SMP workshop on formal verification next month. You can learn more on our website, which is extremely not obvious given the terrible choice of slides. So it's here, it's symbolic.software. or you can send me an email at nadim at symbolic.software if you're interested in learning more. I plan to publish this as an open free tool. You can use it. It's not a commercial thing. You can use it, and I plan to essentially, like, the ultimate goal of this is to create an ecosystem where we have one language in which we describe public ledger structures. We have one standard in which we can reason coherently about public ledger structures. And once we describe these public ledgers in a single sort of structure, in a single way, and we can reason about them in a single way, we obtain outputs that immediately, the Proverif symbolic model output immediately tells us what kind of attacks will figure in the real world on this. And then the F-star output will give us a way to be able to test and prototype our public ledger immediately in production without having any uncertain security parameters. Invalid signatures, non-constant time, implementations of AES, who knows, all that low-level stuff. Thank you for your time.
And up next, Sylvie Chen.
Hi, I'm Sylvie Chen, founder of Clear Karma. So we are a blockchain-backed data management platform for KYC, basic KYC, and GDPR. So it's about data protection. There's a new regulation which is going to come into force in May 2018. It's very soon, and everybody's getting a bit nervous about it because, of course, all businesses which are online, which are digital, like e-commerce, like any startup, is concerned because you work with personal data and transformation and analytics. I guess being some very creative people here with tons of awesome ideas, you probably think of going ICO with some of your projects. And in this case, I heard from a lot of startups who did it that when you do an ICO, you underestimate the cost and the hassle of doing a KYC process, yeah? It's very heavy, it's manual, and it costs, I heard, about like 80 euro per investor, so to do a proper KYC check. So we want to avoid that because we want the money that you earn basically over an ICO just to go into your pockets to fund your project. So without sanctions, that's why basically instead of running your company, you could be ending up running in a prison cell, so we don't want that. And basically we started Clear Karma as a platform for trusted food information. We manage the whole information which is on product packaging. We have a solution, a platform which is industry agnostic, and we found out basically that we can do this information manage this information for traceability backed by blockchain. That's what we have already. We have paying clients, and we found out that basically we can manage this much more easier because it's more standardized than what we manage here already. We have outsourced system, document management, also secured by blockchain, automated translation, neural translation behind it. We want to validate the information with issuers, and we can organize all your reporting scoring, system integration if necessary. So as I said, we come from food, and we have already a working register. We are a third party on the blockchain since December. It's operative. I can show you the demo afterwards if you come to me. And what we put on the Ethereum blockchain is a hash of the documents that we are saving on the cloud, on our cloud. So it's off-chain for the document management. Actually, we have the best mobile OCR technology right now. I've tested it with many other apps on the market. The best rated one for document scanning or even business card scanning. We recognize like already 90%, which is way more than what you usually get on that. Because we started with a very complicated use case at the beginning. You can just get rid of the hassle of doing KYC. You just give us the project for basic KYC. We're happy to do it for you and to do it right, yeah? And as I said, it's 85 languages we can manage. We can do it fast. And yeah, basically, we'd like you to focus on the super projects that you have, yeah? We come from, okay, IT, supply chain, data management, and our development had experience in traceability systems for the pharma industry. That's where we come from, and food. So we're creating a global standard for identity data management, the basic part. We can interface with more, more deeper background checks with other apps. We're open for that, yeah, or other providers. But for the basic check, we can make it for a fraction of the cost of what you hear nowadays, yeah. Okay, so that's it. So if you want to contribute, we're really happy to welcome you in our distributed team. We're between Tenerife, Vienna, Paris, Munich, and yeah, so looking for contributors, looking for people who want to run an ICO, and so we want to help you just to keep yourself out of jail. That's all.
One more thing. So first of all, thanks to all of the speakers, and also just anything that works in these 3 days, anything that doesn't go wrong is because someone put some effort in it. So a thank you to the organizers of EGACC, of which there are a few here.
Oh, do I have anything?
Okay.
Everyone did excellent. Thanks.
And so maybe you were here because you wanted to do a lightning talk, but you didn't really dare to. So here's your chance. The Lightning Talks channel is now the channel of shameless self-promotion. Just share what you're working on and share if you need help, if you're looking for other people. Hey, have a good last day of the conference and see you next time. Bye.